Example A, part C. Are you ready? I am ready. All right, here we go. What do you see? What does it look like? It looks like a parabola. What parabola? Let's just pretend the hole's not there. All right? Let's pretend that we are just writing the equation of a parabola in factored form. Go. What's the 1 root? X plus 2. Okay. So that would just be the graph of that parabola. True or false? Okay, good. So wait a minute. There is a dilation. We'll come back to that. So that would be the equation of this. And then we would have to find the dilation. And we can do that at the very end. All right, we'll do that at the end. But we can't ignore the fact that there is a hole in the graph there. Right? And where is the hole in the graph? At what x value? At 1. That means there needs to be a factor, x minus 1, on the bottom that's going to cancel with an x minus 1 on the top. Because remember, x minus 1 cancels x minus 1 if it makes a hole in the graph. But it can't cancel this one. Otherwise, what would the, listen to this word, what would the post-canceled graph look like? X plus 2, which is just it's a line with a y-intercept of 2. Does this graph look like a line with a y-intercept of 2? No, here's what the deal is. There must have been another x minus 1 that would be canceled. No, only one of them gets canceled. If you feel like being fancy, make the top one say x minus 1 squared. All right? So if we graph this, we should see that parabola with a hole at x equals 1. No, because one of the squareds would cancel. The question was, if it was x minus 1 squared on top, wouldn't it have one of those bouncy roots there? No, because the x minus 1 cancels with this 1. This is really a graph that looks like the graph of this parabola with a hole in it. How do you make the hole? You add another x minus 1 that would cancel. Kind of weird. All right, we're not done because we need to find A. So all you need to do for that is pinpoint where the y-intercept is. It looks like 0, -4. So if you plug in 0 and you get -4, you're good to go. If you don't, you need a dilation. You can do this next step without the red stuff. You don't need this to find the dilation. Just ignore it, all right? They cancel out anyway. So let's plug in 0. What's 0 plus 2? Oh, you remember what we would do? We would actually put -4 in for y, yeah, while we put 0 in for x. So you get -2a equals -4. So there is a dilation. A must be 2. Okay, so the A must be 2. So if you graph this entire thing with all 3 colors, by the way, when you're doing these on your calculator and you want to make sure that that whole top is in the numerator, put an extra parentheses up there before you put these parentheses down there. All right? That will make a parabola that's properly dilated, that has a hole in the graph at 1. What if it was flipped? The 2 would have just been negative dilation.